Hello, dear friends. This is Amir Sheikh, Faculty of Chemistry from Sri Shivaji College of Arts, Commerce and Science, Akola. Today, we will discuss about an introductory part of molecular spectroscopy. So, the first part, you should know about the molecular presentations, how this molecule can be represented in three-dimensionally. So, because for finding any type of a molecule, you should aware about the geometry of that molecule. And before proceeding to this lecture, you should know about the valence electron repulsion pair theory, because this theory gives an idea about type of a molecule, how this molecule can be represented, how this molecule can be oriented in a space, okay, how the position of a lone pair, position of the bond pair, okay, what type of the bond angle is there. That all are nothing but the necessary conditions for what the presentation of a molecule. So before proceeding to this molecular the symmetry, you should just aware about the kind of what molecular presentation that is called the VSEPR. Okay, so everyone should proceed through VSEPR, then and then you will be easier or familiar with the molecular symmetry. Okay, so to understand the concept of what molecular symmetry, so it is a part of what in spectroscopy particularly, so that can be very useful to identifying to calculate the molecular properties. Okay, so basically with the help of what the molecular symmetry, so it is a kind of a, it is a type of the branch of what spectroscopy. Okay, so can be deal with the study of what molecular calculations, molecular properties. Okay, now we have different molecules. There are some molecules are planar, some molecules are non-planar. So let's take the example of BF3 and BF2H. So which one is planar now? Whether BF2 BF3 or BF2H now. So it can be shown here. So now look at this. Now both the molecules are presented here. So in case of a BF3, everywhere the bond angle required for this two fluorine atom, that is fluorine boron and fluorine atom, is 120, while in this case the bond angle is different now. So basically now, so if you just change the one of the atom from that molecule, so that changes their molecular properties. So that is the one of the great thing. So to do these molecular calculations to the molecular properties particularly, so before that you should have to you should have this ability to draw the molecule in a very specific way. Okay, so in the first case, what the molecule is trigonal planar, and all the angles regarding this ones are like 131 picometer. But in this case, this is called a pseudo trigonal planar. Okay, so it isn't planar molecule, but no doubt, but the angle is different. That's why it's called the pseudo trigonal planar one. Okay, so now this molecular symmetries are properties are nothing but they are physical properties. Okay, so bond angle, etc., etc., and by using that it show the different phenomena particularly. So the molecular properties are not the same for this two given molecule. And what is group theory now? The group theory is nothing but what mathematical treatment to the symmetry. Okay, whatever we are learned, whatever we are discussed about symmetry, so we have to apply the mathematical functions, mathematical treatment to that system. That is called what the group theory. Okay, now what is the outcome of this chapter now? So in this chapter, we will first introduce to the languages, fundamental languages of symmetry, symmetry elements, okay, and character table, point groups. So these are the four fundamental parts of your chapter. One is what is symmetry, symmetry elements, symmetry operation, then we have point groups, and finally what the character table. Now symmetry operations and symmetry elements. Now first of all, what is exactly mean of the symmetry element and what are the operation? You know that if you see these two things, symmetry elements and symmetry operation, you will able to find the reason behind what exactly the mean of what symmetry elements and what is the exactly mean of what symmetry operation. Now, symmetry elements are nothing but it is an what one can say geometrical entities. So like point, plane, okay, line, okay. So this is called actually what the symmetry elements. Okay, these are called geometrical entities. While symmetry operations are nothing but that. If you have, for example, in a circle molecule, okay, any circle is here. You know that every circle have the center. So that center is nothing but the element, and just pass the axis through the center and just rotate that molecule now, rotate that circle now. What happened? So that circular motion, that circular phenomena is called the operation. So symmetry element generate the symmetry operation. So if you don't have a symmetry element, then we cannot generate the symmetry operation. Okay. So first thing is that, so symmetry element. So symmetry elements are maybe classified as point, plane and line. Okay, so you should remember these three. Point, plane and line are called the symmetry elements. While with the help of this point, plane and line, whatever we are doing on that molecule to get the equivalent structure, to get the identical structure, that is called symmetry operation. Okay, like this. So let's take the example of a boron trifluoride. It is sp2 hybridized molecule, boron halides particularly. Now it is a trigonal planar molecule. We can draw the triangle here. Okay, so this from fluorine and this one, like you can make the triangle, and passing the this molecule is planar because it is sp2 hybridized system. Now passing through the axis, pass the axis through the boron atom and just rotate that molecule. Now so this is actually the fluorine which is get rotated. Okay, so here see the color of that fluorine. After 120 rotations, the fluorine will be changing their position to here. Again after 120 rotation you will get here, and after the 120 rotation you finally will lead to the identical structure. Okay, so basically, so this is the first structure, this is the second structure. These two are equivalent structure. Okay, the equivalent means what, there is something it changes in there, and finally after that rotation of what 120 you will get what the one can say the identical structure. So whatever identical means, whatever the structures of the first structure, it will be get this one. Basically what in this case particularly here we are doing some manipulation on that molecule. Okay, we are rotating that molecule. The rotation is nothing but the operation with the help of what, which symmetry element now, with the help of what axis which is passing through the boron atom. Always remember that doing during this symmetry or symmetry operations, we are not going to change the center of molecule. Center is always maintained. Okay, center is always maintain their position, while only what there is a changing the position of the bonded atoms likewise. Okay, so symmetry operation is nothing but the what, which is a perform on an object which gives in some configuration which is indistinguishable. That is this one and this one is called indistinguishable configuration, and after that you will get the final one. Okay, and these molecules are what superimposable on origin configuration because molecule is planar. Okay, so this rotation is performed due to the axis which is perpendicular, which is passing through the boron atom. Okay, and perpendicular to the plane. Okay, and that axis is called what, the symmetry element. So here in these two terms simply one can say the symmetry operation is nothing but the rotation, and with the help of what axis we are doing that rotation, that is called the symmetry element. Okay, this one. So symmetry operation particularly is carried out with respect to the point, line and plane now. So basically these are the three geometrical entities. Without that we cannot do any kind of an operation. So basically symmetry element generate the symmetry operation. That's why we are talking about that. If you have the symmetry element, then and then we can do the manipulation, either rotation, either reflection, either inversion, whatever it may be. But you should have the point, line or plane in that molecule. Okay. Now rotation is what? We have what rotation is nothing but it can be find out with the help of a theta, that is an angle of rotation, and that is nothing but the formula that can be with the help of what formula we can be calculated easily. Okay, so with respect to that 360 by n now, so number of rotations now particular, right? So here rotation about the n fold of what axis of symmetry, the symmetry operations about n fold that is denoted by what cn, and which is nothing but the angle of a rotation here 360 by n, right? So here n is an integer, and here that number is can be 2, 3, 4. Example, if you take the example of the BF3 molecule, here 3 times rotation is there, so 360 by n now. So 3 basically what 120. So the angle of rotation should be what 120. So in this way one can be find out the angle of rotation particularly here. Okay. Now applying this notations to the BF3 molecule, here look at this one. So this is the already explained example. An angle of rotation is equal to what 120. Why this is 120? Because to get this same structure we required 3 types of a rotation. One is 120, second is 120, and another is what 120. Now this structure and this structure is called indistinguishable structure. They are called equivalent structure, and final structure is called what, the your identical structure. So BF3 molecule contains C3 axis. C3 nothing but the what 3-fold of what axis of symmetry. Okay. So look at this example, how many C3s are there particularly here with respect to that passing through this. This is the principal axis. Why it is called the principal? Because the more number of order, more the order, that will be the principal axis. And now there are 3 different axes are there, one called C2. Now C2 means we are passing through the 1 fluorine and 1 boron atom. So this is the 1 C2 axis, this is the 1 C2 axis, this is 3 C2 axis. Now C2 means what? So that 360 by 2, because we are have the C2 axis. Okay, and basically This is called what, the subsidiary axis. Okay, now there are two types of what axis are there. One is called principal axis, which is have more order, that is called C3, and second is called the C2. Second one is called the reflection. Reflection, that is through the plane. So reflection is the operation, symmetry operation. While for that we require the geometrical entities plane. Okay, now we have this plane. Particularly, that plane will distinguishes the two equal forms, and that is called what, the plane of symmetry. Now, and the plane of symmetry can be classified in three distinct ways. Okay, one is called horizontal plane, when your principal axis is perpendicular. When principal axis is perpendicular, look at this one. So this C3 is perpendicular to this plane. That's why it's called the sigma H. Okay, it is a horizontal plane. So it is a molecular plane. One can call, why it is molecule? Because all the molecule will be presented on that same plane. That's why it's called the molecular plane. Second, it's called the sigma V. Now, vertical molecule. Look at the water molecule and just pass the plane through the center of oxygen. You will get the two equal halves. That's called the vertical plane now. Okay. So here, let's the example is what sigma V. We are passing this one. So there are two different ways when can be cut the water molecule. Either what this one, either what this one. So look at this. So this is sigma V dash and sigma V. Now there are two types of what vertical planes in water molecule. In similar way, we can take the ammonia. You can take the any other molecule. So whenever you want to do this analysis of what any molecule, if you want to show, if you want to see the exact what type of the fundamental things in the molecule, so you should able to draw the molecule in 3 dimension. If you have that kind of what visualization of that molecule, so you can do this very easily, this symmetry concept. Okay, now look this one. So this is the combined effect. Particularly this is sigma V and sigma V dash likewise. Okay, so this is the special type of what sigma that contain the principal rotation axis but which bisect the angle, and that is called what, the. So now this 2 sigma V can make another type of the plane. This two plane bisects plane is called nothing but the sigma d. That's called the dihedral angle. Okay, or that the angle is called the dihedral angle, and that plane is called the dihedral plane. So let's take the example of xenon tetrafluoride. Again, it is a planar molecule. So first find out the principal axis, and then find out the subsidiary axis, and then remaining properties. Okay. So in this way, in this lecture, we are just talking about some basic concept regarding the symmetry and type of what elements. Okay. So thank you for watching this lecture. If you have any kind of a difficulty regarding this, so let me know first. Okay. Thank you.